Welcome to the SIEM optimization webinar by NXLog. Today I'm going to talk about enhancing SIEM deployments using a dedicated log collection infrastructure. I will start with some SIEM basics, then introduce the challenges of log collection in modern IT environments. I will describe how we can address these challenges and how NXLog Enterprise Edition's features can be used to do so. Last but most importantly, I will do a short demonstration explaining some potential solutions to these challenges in practice. When people think about SIEM deployments, they picture something like this. SIEM is the central component, logs flow into it without difficulties. It collects, normalizes, classifies events, and feeds into automation, manual processes, and more on its output. In reality, this is never quite so smooth. Difficulties rise from the variability of events and protocols and lack of standardization. Some devices are sending cryptic or dense messages, events are spread out over a multitude of files, servers, databases, events might be lost to overflow, rotation when collection is delayed too long, logs might be transmitted over insecure channel, increasing the risk of adverse modifications or eavesdropping, or they might simply be siloed by lack of well-defined access methods or APIs. Most of these issues require flexibility to resolve. This kind of customizability and adaptability is hard to come by in SIEMs or event sources. Quite often, organizational obstacles make it hard to change event source configurations to comply with SIEM requirements. This is why introducing a specialized log collection layer might make sense despite the apparent increase in complexity. The log collection layer can collect, filter, normalize and enrich events before sending them securely over to the SIEM system. This saves time and effort during implementation as well as computational resources in day-to-day use. Source infrastructure, event data and performance needs all pose their own problems. The usual IT infrastructure is heterogeneous and fragmented. Integration is often made difficult by the lack of standardized auditing and collection methods. The collected event data is at risk of theft and modification in transit and at rest. The events themselves don't conform to a single specification, making understanding them difficult. And there is lots of it. Events are plentiful. Many organizations produce security event flow at thousands of events per second. Collecting, processing, storing this data in near real time is a complex challenge. A well-designed log collection layer can address many of these challenges. It can centralize collection, support the native protocols of event sources and SIEM systems alike. It needs to be able to encrypt the event flow to ensure in-transit security. It also needs to be able to convert between formats, parse and normalize events. In implementing parsing, the log collection already takes over some of the computational tasks from the SIEM. It can further help out by filtering unnecessary events and converting to the SIEM's native input formats. NXLog Enterprise Edition runs natively on about 20 operating systems and 4 CPU architectures. It also supports many of the source-specific collection methods for those platforms. It can output data in Ceph, KVP, JSON, SYslog, and many other formats. NXLog Enterprise has encrypted and authenticated transports. It can filter, normalize logs, and convert between different event formats. Its non-blocking multi-threaded architecture, caching, and flow control enables reliable log delivery. NXLog Enterprise Edition runs on all major operating systems in containers and on virtual machines. It collects SYslog, Windows Event Log, various audit sources, databases, files in on-premise or cloud environments. NXLog can be deployed as an agent or as a relay. It can handle hundreds of inputs and outputs at the same time, while parsing, filtering and converting the events. Its scalable architecture enables it to support even the largest enterprise environments. We provide excellent documentation describing integration with many SIEM systems in detail. During the demo, I will show a simple Windows and Linux agent setup and integration with Greylog Enterprise. Later on, I will be configuring a node as a relay, connect a Windows agent to the relay using an encrypted and compressed transport, and I will also show how NXLog can be used to parse, normalize plain SYslog messages, filter unwanted events, and mask confidential information. I will be using 3 virtual machines during the demonstration, one of them running Windows 2016 server, the other one is running Debian 9. These will be the log sources, and I have a NXLog appliance running for receiving and displaying those logs. On Windows, the application is installed in the program files directory. The data directory contains the log files, the internal log files, and the conf directory contains the application configuration. On Debian, the application package is called NXLog, and its files are located in /opt/NXLog. The configuration resides in etc, and the main configuration file is called nxlog.conf. The internal log files are located somewhat further down the file system in /opt/var/log/nxlog/nxlog.log. On our Windows demo system, we have in the configuration an event log input, an extension module to turn the output data into NXLogs, into the NXLog specific serialized format. We have an output module defined that uses the output type exported by the GAF extension, and we have a route to send the data collected by the MS Vistalog module to NXLog. If we start monitoring the logs, we can see that there is nothing going on there. After starting the NXLog service, it shows that it started up cleanly and it connected to the NXLog server. On Linux, I'm using a separate config file for the local modifications. In the config file, there are a couple of extension modules loaded, one for processing the syslog data and one for generating the NXLog specific output format. And then I specify a couple of inputs. One collects from the journal through a syslog socket, and the second one is collecting from the kernel log buffer. The output is configured pretty much the same as it was on Windows. It's using output type GAF TCP to be able to talk to NXLog directly, and then there is a route constructed that connects the journal and the kernel input through the NXLog output. Once this configuration is saved, the NXLog instance needs to be restarted, and we should probably check the contents of the log file to make sure that the configuration was loaded fine. This is what the events look like on NXLog's web interface. You can see that we have some data coming in from the Windows machine, and some of the data comes in from the Debian machine. The Windows events are visibly structured. You can see that there are named fields, and those fields contain values. This is a little bit different from what the Debian events look like. Even though we have a username here, that username is not parsed out by default, and this is because the event source itself, Debian or any Linux system, doesn't really support structured logging. But there is still some information that's present in the syslog header structure that's parsed out and visible on the web interface. This is what we have at the moment. We have 2 event sources, both talking to the NXLog appliance over TCP using the NXLog specific GAF format. But what happens if we need to make sure that some of the communication from the log sources are transmitted in a compressed and encrypted format? We could establish a relay service using our Debian machine, and the Windows events could be transmitted through that Debian machine to the NXLog appliance, making sure that the communication at a certain segment of the network is not transmitted in the clear. Our Linux machine into a relay requires an additional input module to be set up, which we can do in the local configuration. We can see that we already have two input modules from the previous part of the demo, and this is where I can just go ahead and add another input using the batch compress module. This is already configured for secure communication. We have the certificate, the key provided, the CA certificate for authenticating the connecting party, and we also have the key pass specified here, so we can open the password protected key. In addition to that, I should add the input module to the route specification so that the data that we collect through that port will be transmitted to NXLog. Saving the configuration, then performing a restart, then checking if everything loaded fine. So you can see that all is working well. Next, I have to configure the Windows NXLog instance to send data to the Linux instance over the compressed and encrypted protocol. You can see that this is now the Debian machine's IP address. Otherwise it looks pretty similar. This is an output module that I'm going to configure. And this is in fact going to replace the original output module that I was using for the native NXLog output. And now I have configured it to send data over. I can save it. Restart the service and see what happens there. You can see that the batch compress module started talking to the Debian system. Let's check if we are still receiving those Windows events in NXLog. To see what is going on with the events, I will generate a bit of traffic using SMB client on Linux. So now, if I search for events here, I should see something authentication related. Right, so we see a login message that came from my machine here. And it was targeting the administrator user. So the structure remains intact, and we are now receiving these messages through the relay that we configured on the Debian system. At this point, we have configured the Windows 2016 server to transmit its logs through a compressed and encrypted channel to the Debian 9 system, which in turn will send it on to the NXLog appliance using GAF over TCP. Structured logs are especially useful if you want to find something very specific in your log stream. Like finding the events that involve the user administrator could be formulated in a search query like that. Once the search completes, you can see that there are only very few events here. I also have something that's generating noise for this particular user, SSH logins. But you can see that this cannot be found this way because that particular log is not structured. We have it in the full text, but we don't have it parsed out as a specific field. So if I want to introduce parsing into the log processing for this event type, I can use NXLog Enterprise Edition to do that. If you look at this config, we already have an exec block here, and I can just insert the additional parsing logic here. This is just a comment, an example, a piece of example code, and I need to close that. And you can see here that the logic that I'm using is relying on regular expressions. It's looking for the first word that comes after the string, then extracts the initiator host, then the port number, and the authentication method, then the key. So if I save this and restart NXLog, you can see that this is constantly generating SSH logins for me, so I will have something to show. And there we go. We have a few log events that already contain the parsed target username that I just extracted. In addition, it also contains the SSH version, the SSH key text, and the authentication method parsed out. Filtering logs is a very useful feature in many ways. Quite often you have bits and pieces of misconfigured software or automation that generates noise that you don't really care about. Storing this noise in your SIEM system makes life a lot more difficult, because after you store it in a database, then you will have to keep avoiding that in reports, in dashboards, and you will also have to probably pay for storing that data. So in our example, I'm generating a constant stream of authentication failures coming from this particular user, and we can see that this is going on. It keeps happening for a long time, and this is not something that I want to collect and store. So the easiest approach is to just go ahead and filter this out as close to the source as possible. In this case, we can do that on NXLog, the NXLog agent that's already deployed on my Windows 2016 machine here. I'm specifying the event ID for that authentication failure and the fact that the target username is administrator. We have to be careful not to relax the search parameters too much, because then we will be throwing away information that we wanted to keep. But if I configure this and then restart the service, I can see that it starts up okay, and I can also see that it shows up in the log, when the internal log, whenever there is a bogus login failure that we are dropping. In exchange, we should have the stream of events stop here after a while. We shouldn't have any more showing up after the point I deployed the filter on the event source. Next, I would like to show you how NXLog Enterprise Edition can be used to mask confidential data from the log stream. In our example, we have a process that's logging credit card numbers into the syslog, which is clearly sensitive data, and we want to redact it as close to the source as possible, and we don't want to transmit it into the SIEM system where it will be retained for months or even years, or maybe even permanently. So what we can do here is configure a filter on the source that's generating this traffic, and just like we did before, we can add an additional parser here that's looking for anything that contains a credit card number format, and it will log a warning into the internal log about the fact that it's found something like this, but it will also remove the first 3 quartets of the credit card number and replace it with this string. Once we have saved this, we can restart NXLog, take a look at the logs, see what's going on there. You might have to wait a bit because it's running every minute. You can see that, okay, it appeared here. Now we can check it on the web interface, what happened there. You can see that the latest one of these events has the credit card number redacted from the full message. Keep in mind that this doesn't mean that this hasn't been logged anywhere else. So if not all of the logs are going through the NXLog collection system, but there is some of the data, there is some data that's logged locally on the source system, this would avoid, that data would avoid redaction. But this is a pretty good and dynamic method for cleaning sensitive data out of logs that you will store for the long term. NXLog Enterprise Edition is a great match for the challenges of event collection in heterogeneous environments. It collects from practically anything, transforms and processes events, then securely and efficiently passes them to the SIEM system. Its capabilities can make any SIEM system more efficient and easier to operate. We are a proud integration partner for many leading log and event management system providers. You can read more about SIEM and NXLog Enterprise Edition in our white paper, SIEM Optimization with NXLog. We are proud suppliers for many large enterprises and government organizations. Some of them we are even allowed to show on this slide. Thank you for your time and attention. We hope this webinar will help you get started with NXLog Enterprise Edition. If you have any questions or requests, you can reach us through our website, where we also host our excellent product documentation.